Adam, where are you dialing in from today?
So I am in my brand new living room. We just moved house. So
Congratulations.
15 miles north of Seattle.
And how's the weather in Seattle?
So it's a rainy day, but on a rainy day in Seattle around dawn, it looks like this behind me. This is actually taken from the transit center near my house.
Beautiful.
Like this isn't like some fancy downloaded background. This is just a cell phone snap.
So I love the story of how you all met while everybody still joins here. We're seeing the participants kind of trickle in.
I can fill in a little bit of backstory there. So I've been going to events with No Fluff Just Stuff with Jay Zimmerman. Great series, by the way. But I've been going to that for like a decade at this point, from back when they were a little one-show game in Denver. But so I've been going to these forever, and I started going to ArchConf when it moved to Florida. I don't know, 5 years ago, something like that. But so we're all hanging out after one of the days, and Jay decides he really needs Justin to meet me. So
Jay's good like that.
Around his bar, and I'm standing there. We'd been chatting with a bunch of the other presenters, and Justin introduces himself. And I don't think he thought a lot was going to come of it. We just chatted, people at a conference. You're always nice to everybody. But then Justin, I was in one of his sessions later, and I kept raising my hand like every time he wanted input, because that's kind of who I am. I don't know, Justin, if you want to talk to that a little bit.
No, I mean, I think you nailed it. I mean, it was great. It was one of these things where we're having the way that you really want a talk to go at one of these sessions, where it's not just you with slides talking at the audience, but you've really got participation. And Adam was like, into the conversation, adding a lot of good like detail and color. But at one point I was like, wait a minute, who are you and where do you come from? And we got kind of more into this, real discussion about the work that Adam's been doing for Meta specifically, and how that related so closely to what we were talking about with productivity. And it was like, you gotta come on our lowdown. And so here we are.
Yeah, and I remember Justin messaging me and saying, "Hey, I met this gentleman. We gotta have him." So
I think you were standing in the room at the time, and he's slacking back and forth with you while people are like coming up after the presentation and getting swag. Yeah. We had some Gradle stickers and a couple cool shirts.
That's kind of the pace of things now. Yeah.
So we're 5 minutes after we should get started. Thanks to everyone for joining. Ruse and Justin from Gradle on the Develop Productivity Engineering webcast. And why are we here? Just want to spend a few seconds there, right? From Gradle's side, right? We wanted to share with the whole world about productivity engineering, our wins, findings, experiences. We want you all to invest in Develop Productivity Engineering developer experience, and why that's important. All right. And today we have Adam McCormick, works on the Facebook mobile reliability engineering team, and they essentially have one of the hardest developer productivity engineering problems and developer experience problems on the planet, with their just Facebook alone, like almost 3 billion active users, right? And so it's no secret that how fast Facebook is able to innovate and ship software at scale. It's really hard when you get to that size. And that's one of the reasons why everyone should invest in productivity engineering developer experience, to keep your top talent and keep your top engineers more productive. And that's why we're here today. We wanted to share that with the whole world. Thank you, Adam, for joining. There's also a Gradle community Slack workspace. It's open. Anybody can go there. There's a developer productivity channel in there. We're not going to get to all the questions, right? Super hot topic. Everything that we were chatting yesterday with Adam, everything that he's talking about, it's going to be super interesting. There's going to be a lot of questions there. So we're going to try to take Adam into that channel and try to get him to answer as much as he can, right? It's no promises. He's already given us an hour, which is more than we can expect. But anyway, Adam, why don't you tell us a little bit about what you're working on and your team at Meta?
Well, sure. So I'm sure everybody's familiar with Meta, or as people used to call it, Facebook. I work on the Facebook app reliability and engineering team. What our big goal is to minimize the number of users who experience crashes in a given day. And that sounds like a simple task, but when you think that across Facebook we've got 3.8 billion users, you have to do that at humanity scale. And so that's a question of working with a lot of different product teams, working with a whole lot of data, and trying to optimize, build in that kind of reliability and good practice before the code ever reaches the point where it's got to be reviewed. Like, we don't have the luxury of a lot of soak time or long release cycles. So we live in that world where you have to build in quality. My team specifically spans a lot of products. And what we do is we work with our product engineers to establish those real best practices and to help them investigate when they mess something up. Part of moving fast, which is something that we pride ourselves on, is that you're going to make mistakes. And so a big thing we do is try to help you figure out where you've made mistakes and then avoid them in the future. I work specifically on Android for the Facebook app, but our team is kind of the masthead of the reliability organizations. So we work heavily with the reliability groups in Instagram, in WhatsApp, in Messenger, in Oculus, to try and share a lot of that knowledge. Because the Facebook app, people maybe don't realize that Facebook app's the most complex Android app there is, period. There isn't a more complex world to work in terms of the Android space. And so it takes a certain amount of hard work to get to the point where we can even release as fast as we do. I was reading one of our dev blog posts the other day, and we used to release monthly, and it took the better part of years to get us to the point where we can release every week. And then we start butting up against the actual infrastructure problems of our release systems, where Google and the OEMs and all the devices won't update faster than that. Like, there's a point at which we've pushed those needles as far as we can possibly push them. And that owes to a lot of investment when it comes to productivity and, the actual dev life cycle.
Great introduction. One question about, just releasing. When you talk about release every week, are we talking about major releases? Are we talking about minor releases? How big are these releases?
Well, let's put it this way. On Android alone, we do between 30 and 50,000 builds a day. And that's not an exaggeration. That's a solid number from 2 years ago. It's probably more now. We do about that many builds. Every particular change, what we call diff, to our system gets between 3 and 5 of those builds on its way into the master branch. We block them at diff time, we block them at land time, and then we roll them out slowly into a master branch, which we then cut alpha, beta, and prod from. So over the course of a week, a particular revision will go into an alpha, which goes to a lot of internal users and a huge automated testing community we call Sapiens, which is sort of simulated humans. We do a beta cut, and then that sits for beta for 1 week, and then we push to our stores. That means we push to a bunch of the OEM stores where they pick up the actual newest release, and that goes directly into their devices that they're selling on a given week. It goes into the Google Play Store, and it goes into a system we call Oxygen, which is how we work with Android devices that don't have access to Google Play services, things like Amazon devices. And that lets us roll out those new updates once a week. Most OEMs won't let you update more than once every 7 days. So we're really talking about what we look at as a major revision every week. Minor revisions once a day to 2 or 3 times a day in alpha, and then up to 4 and 5 times a week in beta as we discover major things that we don't want to release without getting side events. And our team is hands-on through that entire process. We're the ones that govern all of the check-ins that want to go into beta and all of the hot fixes should you ever need to hot fix prod. And that's a very hands-on process, and it requires us to know the entire universe of our app to a pretty deep extent.
And thanks for sharing that, by the way. And that's a great segue kind of to the next topic, is to ship at that scale, that frequently, with those types of features and cadences and whatnot. You need support. It's not just, you can't just throw thousands of engineers at it. Tell us about productivity engineering, reliability engineering, and developer experience kind of orgs behind it, supporting all these developers to getting them to be that successful. What kind of investment are we talking about? How many folks are in those organizations, right? And part of what I want to share with the community is, hey, there's a reason why Facebook can ship at this scale and innovate this fast. You can't just do it with just throwing 1,000 engineers at it. You need this investment in productivity engineering. What are we looking at there from your side? How is it structured? How many people are in it? How does that work at your organization?
Well, so it's actually funny that you say throw 1,000 engineers at it, because that's about the size of our dedicated productivity engineering group. And I won't go into exact numbers because it fluctuates quite a lot. But within our infrastructure org, which is 30,000 of our 100,000 employees, there's 1,000 people who we dedicate just to facilitating developers releasing code. That's everything from tools that we use for testing to our internal modifications to all of our development environments. It's sort of an interesting world because we run a huge monorepo. We run a world where all of the code for Facebook, all of the code for Messenger, all of the code for Instagram and Oculus and WhatsApp and 100 other little products that you've probably never heard of all live in this one gigantic repo, right? There's no world in which you can build all of that or even download all of that on most machines, hundreds and hundreds of gigabytes of code, right? So the kinds of investments that we've had to make are everything from rewriting our source control system because Git can't handle, just cannot handle a repo the size of ours. Working with open source groups, in this case Mercurial, to fundamentally rebuild the source control systems that we use and integrate with our internal build system, a system called Buck, that again, we had to rework because of the sheer scale of what we're producing. And then all of these servers and clients and systems that make it so that you can reliably build code on your local system, or even on what we call on-demand servers, which are pre-warmed images that then you don't have to download a lot of code onto. You start them up and they build. And all of that is a huge investment that nobody else has to make at some point. We have a dedicated group who does nothing but keep our system running on what we call stable, which follows master by something like 2 hours, and make sure that we are generating all of the various artifacts that go with that, so that when a typical dev wants to do a build, we're only building the very, very small parts of the system that have to be rebuilt for them, and all of those other artifacts are coming down. At 50,000 builds a day, it is not possible for you to follow master as yourself. You can't constantly keep up with master. You can keep up with stable usually because, up to 2 hours lag. But even then, you're never going to be able to rebase onto master and hope to ever merge it. So we have to have systems that do these things automatically, that do merges when it's possible without you having to intervene. We have to have automated testing. We have to know exactly how much of the code you touched and which artifacts have to be changed. We have to know all of these things just to be able to check in one piece of code. Now you add to that we've got thousands and thousands of developers all working simultaneously in the same repo and all moving master even when it's not your group or your specific piece of the baseline. And the investment involved ends up being the full-time job of whole orgs of people. We've got director level folks who are solely responsible for organizing those efforts. And there's a reason we put it into our infrastructure org. The 30,000 people in our infrastructure org all have the same goal, and that is to facilitate everybody who's building Facebook to deliver Facebook. And not just Facebook, but WhatsApp and Messenger and Instagram and everything under the Meta umbrella. That's 30% of our workforce is completely dedicated to making everybody else successful. It's not one guy. It's not five guys. It's not just everybody kind of does a piece of it and all the developers have to know what they're doing. It's dedicated workforce.
Nice. No, that's a great kind of overview of what it takes, right? And of that scale, right? You have to build your own in many cases because it hasn't been done before. We're getting some good questions, Justin, around building and testing. Before we get to those, maybe we jump into this next topic of what's it like in the day in the life of a Meta software engineer working on the Facebook Android app, right? How do they write code? How do they write builds and tests, CI/CD?
Well, so let's take a section out of more of a product engineer side of things, because on the reliability engineering side, our day is atypical. We do more investigation than we do writing code. We write enough code, but when we're looking at delivering a piece of the system, there's a couple different ways. One is you can build the code locally. You can write whatever changes you want, deploy them to a phone, and it works. That is facilitated by the fact that we have a customized version of Android Studio that lets you bring in all of these artifacts using Buck. We have dedicated configurations of that system that bring in all of our lint tools, because normal linters can't handle our code, that bring in our compilation tools, that bring in all of our handwritten modifications of the AST, and then also integrate with an emulator in a way that doesn't break Facebook. It's because Facebook is such a complex application, it's actually pretty difficult to run an emulator that will support Facebook and not crash. And we're adding in the complexity of a bunch of debug information and non-optimized builds and not minimized code size. And that pushes the boundaries of what a lot of devices, even new devices, are really capable of running. So as a dev, you might take a new feature you're trying to build. You might build that locally, or you might check out what we call an on-demand server. An on-demand server is basically pre-warmed code, where you can do whatever development you need, mostly in our, again, customized version of VS Code, that you would then build whatever you needed to do, be able to run your tests locally, run your Android in server mode, and then run whatever tests against it. We have a whole end-to-end testing framework wherein any individual test can be run against your code, or suites of tests on the server side without explicitly having to run an emulator. Because again, there's just so much infrastructure. If every individual had to run an emulator, we'd have to buy everybody Mac Pros. And that is, not really feasible. But while we're running them all on Linux, we can split off our relatively sizable infrastructure and all of these data warehouses and server infrastructures that we have, and we can shard those out to individual devs. Now, something that's interesting, I used to work at Amazon. At Amazon, every team has to own their own machines, right? You have to know about each of your instances and each of your clusters, and you have to set up your own pipelines. At Facebook, there's the trade-off of, well, you don't get as much control as you get when you own all of your own machines. But in exchange for that, you don't have to worry about it. If I want I need to work on 3 projects at once, I can pull 3 individual on-demand instances, and they'll get pre-warmed either with a diff in progress, diff being what we use to talk about a change request or a code review in progress. I can pull a diff down. I can run it in an on-demand. Doesn't matter whether it was mine or not. And that takes, 2-3 minutes as opposed to the hours that it takes to download our entire baseline. When I was in boot camp, the first 5 weeks when you're employed at Facebook is kind of a boot camp to get you familiar with all of this tech. It took me 8 hours to download and compile the Android baseline. And that's because I didn't know what I was doing and I wasn't leveraging any of this infrastructure, but 8 solid hours doing nothing but downloading and compiling. Where when we compile with the normal system, 5-10 minutes. And you've got a working system. When you pull from the stable baseline, if you pull it raw, 0. You press go and it just comes up. Because if you don't have changes, we don't have to rebuild, and all of those artifacts already exist, right? So you've built your code. You've either built it locally and you've run it on your own device, or you've built it on demand. Well, so then you push it. Now we have a system that we call diffs. Again, completely homegrown, because everything we do is just a little bit more complicated. Because sometimes we run what we call code mods, and you can have thousands and thousands of files touched, right? So that breaks almost every online code revision system there is. So we have our own, which we call diffs. And diffs then can be reviewed by any number of people. Every piece of code that a dev touches gets reviewed. And we've actually added an additional step now where we call what we call final review, where if you modify your code after it's been accepted, it has to be re-reviewed before it's considered okay to have in the baseline. When you submit a diff, in the background, the infrastructure is already going to run a bunch of basic tests. It's going to check linting standards. It's going to check whether all of the products that you touched compile. It's going to check whether you are significantly affecting various performance metrics. And it's going to run a basic suite of tests. Then once you have approval and someone's reviewed all of your code and you've gone back and forth and you've done all of the niceties of code review, you go to land, what we call land. That's the process by which you go from a diff to a merge, right? And so we've got another more strenuous group of tests at that point, where then we're doing a full compile and we're making sure you don't regress app size. Then we're doing smoke tests across our entire fleet of apps to make sure that you didn't break a bunch of other applications. That's when we're making sure that you aren't significantly regressing production metrics as we push that into the master. Then you've landed. That process can take anywhere from an hour to 4 hours, and we have ways of making that faster when we have reason to, when we're in the midst of a sev, when we're trying to fix something or move very quickly. But you got to think we're building all of this infrastructure and then we're running tests against it just like you'd run tests on an emulator, right? And at 50,000 of those a day, that's a huge amount of processing power that we're throwing at the problem of speeding up this end-to-end diff to baseline. Now, most of the time, that diff to baseline is going to run around 2 hours. But that means that for a modest change, especially if your team already knew about it and the people who were affected by it already kind of knew it was coming, you can post a diff, make the change, get it reviewed, and deliver in 2 or 3 hours. And then we start going live, right? So on the Android side, we split out alpha revision at least once a day, often 2 and 3 times a day, depending on how broken the system is right now. Because again, we move fast, things break, and we try to make sure that the most recent version of the alpha build is working, at least mostly working, because it is alpha after all. Every week we cut a beta, and then we cherry pick into that beta to fix things that are wrong with the beta. And then a week after that, we release to prod. We cut the beta and the prod on the same day, generally. There are places where we've started to shorten that, and the distance from beta to prod is product to product now, but anywhere from 3 days to 7 days. And then once it's in prod, that goes up to the store, and we do a progressive rollout, 1%, 10%, 100%. Now we have a breakdown in that. It's not quite as simple as rolling all of Facebook out, but that's way down in the weeds. But you can see at each of these steps, it's always gradual. It's always deliberate. Every single one of these releases is a little bit of a canary, check the metrics. A little bit more, check all the metrics. A little bit more, check all the metrics. And at every one of these steps, every one of these branch cuts, when we're going to prod, we've got a lot of instrumentation. We know exactly how often users are crashing. We know exactly how many stalls there are, how many CPU spins, whether various top-line product metrics are changing for these users. And that's why it's critical to have these people who are participating in our betas and our alphas, because otherwise you're guessing, and we don't guess. We really don't. If we had no data, we would not move. Every single week we have these meetings, and they're entirely driven by all of these measurements, and we stick to them until we can actually explain a discrepancy. We don't ship.
It's that scale. This is what you need, these kind of processes in these tools. One thing that resonated really well with me was when you mentioned, hey, when you first started, you tried to just download and compile this. It took 8 hours. But then after, with Facebook's investment in these acceleration technologies and tooling, they're able to do it in 5 minutes, which is, why we brought you here today, to say, hey, if you're trying to do things the normal way at that scale, good luck shipping, good luck trying to compete with Facebook, right? Without investment in those tools.
Crazy to see, like, hearing these stories and kind of just seeing it made real, the techniques that you're using. I loved hearing about that, like, kind of like slicing a little bit more canary at a time, as opposed to like full canary. It's like, no, we're just introducing little bits, almost like features kind of trickling in. Can we take a quick break here and kind of hit a few questions?
Let's say we have so many, Justin. I don't know if we're going to get to them, and we haven't even gotten into them. Yes.
A specific one that came in was just a little bit more clarity around the Sapient system that you mentioned. Just to clarify, you do mean that these are simulated human users. Yeah, and wondering what technology that's based on. Specifically, is it based on monkey, like the Chaos Monkey?
So and that's the thing is, I'm sure that the name was originally a little bit of a play on Chaos Monkey. There's a lot of cross pollination between Netflix and Facebook and all the other manga companies. But the big thing about Sapiens, right, is that we have what we call QPL markers, and QPL markers stands for Quick Performance Logger. Has nothing to do with quick or performance anymore. But the point is that what they do is they record human action. When you interact with our application in various ways, we anonymize that data, and then we can aggregate how much of which parts of the app are used. And so we take the most firing QPLs and the biggest workflows, and we've taught a simulated human system. And these aren't humans. It is effectively an end-to-end test that runs against an emulator, but it's not scripted. It's trying to tie together all of those QPL markers. And it learns how to walk through them and simulate the way a human would use the application. And by doing that, we're able to take our alpha, which is a very small group of users. That's really employees who have opted to take this somewhat broken baseline that is really actually often quite broken, and increase the number of users and the number of hours used. And really, we think of this in terms of the number of hours interacted with when we're talking about these alpha releases, and up it by an order of magnitude. Actually, in the case of what we call virtual alpha, we're up to 3 orders of magnitude. We have 1,000 times as many hours as we from our Sapien system as we have from humans on our alpha builds. And without that, there's so many features that are never used by employees or just not used enough to drive out bugs and these changes. With the Sapien system, we've been able to find a lot of those regressions far earlier than we would ever have a chance to if we waited for our beta population. And we've got a lot of beta. We have a public beta that folks can sign up for from the Google Play Store. And that allows you to see some of this stuff a little early. It's a little bit crashier than the production version because it is our soak and our it's the maturation phase of the app. But every week we're shipping that, and that's where we get the lion's share of our I don't know exactly what the word is, the polish of on the end of the app. But without the alpha, without Sapiens running on alpha, that beta build would have to take weeks because we just don't have the ability to force people to use the alpha build. And we wouldn't want to. At some point, our goal is to try and make a clean experience. We goal on things like touch responsiveness, on how fast the app comes up, on the number of users who ever experience a foreground app death, the number of warm starts, which is to say how good we are at using memory and thus how infrequently we are killed by the operating systems. Like our goal comes down to sad users and bad experiences almost 100%.
There's one other thing. Several people are wondering about how you handle rollbacks in this process and what that looks like.
Well, so I think what we would talk about, we actually call it unlanding. So just the same way you would revert in a Git repo, you check in a revert commit. And then those land just like anything else. But the trick is that because we're working on a mono repo and it is effectively linear, we don't really have a proper branching model except for the cuts for releases. We roll everything on the end of master. So if you have a change that needs to be reverted, we build an inverse change and we land that. Now that can get tedious because again, the tip of master moves really fast. So again, this is a place where our productivity engineers have come in and helped us build these systems that automatically create these things. When if you have a particular revision that breaks a lot of tests, even if you didn't notice that, we're doing something we call multi-sect, which will find which revision broke a particular set of tests on our master branch, and it will proactively generate revert diffs, where all anybody has to do is hit go, and your diff unlands. It's not. There's a problem in a lot of software that is kind of addressed with the mono repo by saying, look, breaking changes are going to happen. There's going to be times when the sequence of changes in master are not going to be usable, that they're just going to be breaking changes. We don't try to create the fiction that master was always stable and that master was perfect. We don't try to revert out the history. We don't try to get rid of those changes. We keep them. We keep everything. And we just have this very, very long linear path that is our master branch. And so when you break something, we revert out only the parts that you touched in a later revision. And that means that every build after that, since everything is based on all of these stable artifacts and nobody is, building these long-term branches that are based on some ridiculously old version of master, we're constantly doing rebasing. We're taking everybody's diffs and we're constantly bringing them up. We're constantly moving them forward. We don't even allow people to land if their current diff is based on a master that we don't have those artifacts for. It's not worth the compilation time to try and do that. Everything gets rebased and moved up to stable versions. One of the beauties of the on-demand system that I mentioned is if you pull a diff down in an on-demand, it is rebased as part of that process. So the first thing you do when that on-demand comes up is fix any conflicts in the rebase, which usually there aren't many unless you are working on a very hot piece of the system. But that means that as we move forward, we revert by fixing effectively. And if you've got a fix that can do it faster than the revert or that's smaller than the revert, you fix forward. And that the difference between the two is only a question of whether we know that the fix is going to revert what you did. So we live in this world of, if you regress the metrics, we have to roll back, but also we don't want to be in the business of everybody doing that manually.
That's, I mean, how it's like straightforward hearing the answers, but then it's like, you think about these problems at scale, and then it's like, okay, what else are you going to do? So anyway, yeah, Ruse, maybe we go back to the main line.
So we got 3 topics that we want to go into, and we got 20 minutes left. We usually wrap up at this point and go into Q&A, but we haven't even gotten to our favorite topics of productivity engineering, metrics, and whatnot. Before we get into that, Adam, in 2 minutes, can you talk about the highlights of the tooling stack? You mentioned Buck, and the Buck 2 is now, Buck 1 didn't scale. I guess they have Buck 2 and customizing Mercurial for version control system. In 2 minutes, give us what other highlights of the tool. I mean, I know we wanted to go through all the tools, and probably should have another webcast just for that. But what can you give us in 2 minutes highlights?
Well, so the biggest thing is we have a customized version of VS Code, and it let us integrate all of our internal tooling. That includes custom auth, Buck integration, something we call interactive state logger, ISL, whatever ISL stood for in our universe. But that lets us look at branches and look at revisions and pull diffs. We have a system called Jellyfish that is sort of the link between code revisions and diffs. And that had to be, again, custom built. We've got Mercurial that actually is tracking the data. We've got customized version of Android Studio that does our actual Android builds using Buck, but also understands enough about the Android ecosystem to let you debug those builds when they go onto a device. We have on-demand servers, which are the bread and butter of our development process. Then you've got all of the other ephemera that goes around this stuff. So then you get into the really neat stuff. When we do a code search in our repo, because everybody wants to be able to search from code, all of our code searches are directly integrated with those development tools. So if you're looking at a piece of code on the web, there's a button that'll take you to that same piece of code in VS Code. If you're looking at code inside of our error reporting tools or inside of our search tools or our data analytics tools, you can link directly to that line of code in your editor. And if you've got an on-demand up, it'll be the version of that that's in the on-demand. So, I mean, taken all together, what this means is that we don't have 57 workflows for 57 different tools. You have the way you do business, and we've tried to enable as many of those as we possibly can, which just lowers the friction of the whole system.
Jumping into productivity engineering and developer happiness, how does Meta, and maybe specifically your team, right, measure productivity engineering and happiness? What data are you looking at, and where does that data come from?
Yeah, so let's start with really simple stuff. We have a developer-wide survey that we call Pulse. Now, everybody does developer surveys, and they're basically nonsense for most people, right? But Pulse at Meta is different. We actually ask people, do you like the way that the tools we have are serving their purposes? And then we give that feedback directly to those tools team, and those become actionable. We ask people why they're not being able to do things the way they want to, and then we move those systems based on those numbers. We take our broad surveys as the core goaling metric of our entire management organization. They're not gold on features delivered. They're not gold on how many people do how much code or any of that. They're gold on the pulse, on the literal pulse of the system, right? And then throughout the quarter, we do what we call micro pulse, which is just little check-ins. How are things looking today? Was today better than yesterday? Was this week better than last week? how is this looking? Have we improved on this? That is our thing we're trying to work on this half. Constant influx of data, right? But we know that when you ask somebody something in a survey, you get conflated results every time. People are going to conflate, I'm happy with my job, with the tools are good. So we're also looking at ways of trying to lower the friction of the day-to-day development experience. We have a bot called BalanceBot, which monitors how often you're getting notified, how often things are flowing into your queue, be that on our internal chat app. You'll notice the theme here. Everything's custom. Our internal chat app called Workplace, our internal social media system, which unlike most companies, we actually use it as our core communication framework. Whether you're getting too many notifications on that, whether you're getting too many notifications via email, whether you're getting too many reminders set from various sources. And because of this, it actually will tune those down. We've set it up so that if you've joined a lot of groups, it'll ask you, do you want me to just mute these for you? You don't really interact with these a lot. Do you want me to just turn off these notifications for you? And that automatically sort of does a lot of the housekeeping stuff that you do for yourself. No, I don't want to hear from this one. I want to hear from this one. I never look at these. We don't lose any of that productivity because we've got a bot that's doing it for us. We then add what we call Focus Bot, which is to say we watch when our users are not listening to their notifications, not immediately responding to their notifications, and when they're actively working. And we start muting those notifications and we let them work. And we'll establish what we call focus blocks, where if you are really in the groove and you're starting to code and you're just doing the work and you're not focusing on any of that stuff, the volume of all that stuff just goes down. And more than that, it communicates to others who try to contact you that you are in a focus block and that maybe they shouldn't expect a response right now because you're busy, you're doing work. And what that does is it makes it so that doing the right thing is easy. Doing software the way that is effective is easy. It's harder to make sure that you're answering every email. It's harder to make sure that you are constantly on the social media or the chat system trying to talk to people. You can still do it, but it emphasizes the work of building the system over those distractions, which is fantastic from a sheer overall productivity perspective. And we measure this, like we measure everything. We know when the group that has BalanceBot is producing more and getting better ratings than the group that doesn't use BalanceBot. And I mean, all this stuff is optional. You can turn them all off. You can say, I don't want this. You can disable these things. And they actually ask you whether you want to, because for us, consent is everything. But when you have these things enabled, we're able to show you get more code written. You spend more hours writing code. Your code has less diff comments. Your code doesn't need to be reverted as often on the aggregate. All of these measures that can say, can you focus? Are you building what we are intending to build? And on the aggregate, are you a happier developer? Because a happy developer is a good developer. And that means a different thing to everybody. But for most of us, I think it means, can we do the job that we like doing?
Nice. Yeah. I mean, we know context switching is a killer, and thinking of how to decrease that noise is on Facebook scale. Very interesting. Thanks for sharing there. Any interesting productivity engineering wins that I know you talked about the no code stuff and the Sapien stuff. Any other interesting wins based on data that you all have seen and things that you implement that you can kind of share with us?
So I think the biggest productivity win that I've seen here is the integration of the apps themselves. And I mean, I know I've touched on the monorepo a little bit, but the thing is that when we're building these systems, everybody kind of eventually acknowledges that you're not going to reuse as much of the code as you think you're going to use, right? You're not going to actually reuse that method you wrote 15 years ago today for what you're writing. But a big chunk of what we've tried to do is to take all of the common stuff that we don't want people reusing and make it transparent. So we have tools that make it easy to write one-off SQL scripts. We have tools that make it really easy to build complex data flows to do analytics without establishing new hardware or new infrastructure to do it. We have focused on flexibility over purity of ideal. So we have a system called Bento that is one of the big things that productivity engineering came out with that lets you just run data processing. And you can run it in C# or C or Python. You can run a SQL query. You can pull the data into your system, and you can build these very useful scripts with a certain limited amount of libraries that are available, and do simple visualization, and then save those and share them. That keeps us from having people build custom data systems, trying to download their own versions of every single library in existence, having their need to write custom SQL code everywhere. All those integrations to get the data unified, because it's actually easier than them writing them themselves. The code is easy to port, and the solutions can be shared, so we're not having everybody run their own. So that's one of the biggest wins, in my opinion, is that kind of infra. It's infra targeted at the facilitation of what your users are going to do, whether you want them to or not. I mean, and by users here, I mean the developers.
Thanks for sharing that. I have one question from our folks, Justin. I had to get this one in. Our folks have been, said, don't let Adam leave without him answering this one question. Wait, and of course we're the company behind Gradle, right? So obviously interested in build, test, acceleration technologies and whatnot. How long does a Android PR build take? And what are you all doing as far as acceleration technologies go to make this thing, that process and the feedback cycles to be as fast as it can be? What tools and technologies have you developed?
So I think we've talked to that a little bit.
Yes.
But here's the thing, right? If you were to check out an on-demand right now, just a blank on-demand, no code changes, and you were to try and build the Facebook app, it's going to be less than a minute. Seconds. Now that's building the most complex Android app in existence in a few seconds. Now, getting there means that we have a custom build system that relies heavily on artifacts that are all cached and built constantly into what we call the stable. And they're really checkpoints. Our stable points are checkpoints for each given app where we say this is a version that everybody should be basing their work on. And everything past that you're building, be that from master or be that from your own changes, has to be recompiled. So we take as much of stable as we possibly can. We take the little bit that you've added and or changed, and only that little bit is being actually recompiled. So on a typical change, you might do a lot of work and you might need to recompile a lot, and it might take 20, 30 minutes to fully recompile that. But then the next build will be 5 seconds. Because we can't. We literally can't afford to build all of the code for every change that's made. And I mean that in a literal monetary sense. Running all of these builds from scratch is financially irresponsible. And honestly, it's an irresponsible thing as stewards of the planet. I think there was a study by Google a few years ago that their AI system was generating something like the entire heat footprint of a small country just to run their AI models. When we're talking about humanity scale data processing, we can't, it isn't just, financially bad. It's irresponsible to run that excessive computation. And so we measure those things. Every single feature we look at it in terms of how much server-side CPU it requires in order to do its job. We look at how much on basis a dev environment is costing in terms of how long it's taking to compile, how long diffs are taking on server-side computation hours. Not just human hours, but energy usage, because those end up being the core drivers of success for the system as a whole, even if it's not the best thing monetarily.
And Adam, this will actually help with one of the audience questions too. How much of that time saving is caching versus build caching specifically, like not dependency caching or anything like that? How much of that time saving is build caching versus some of the other accelerating technologies that you've got in there?
Well, so I will admit that we've had entire groups, 10 and 20 people at a time, who have optimized the actual compilers to an obscene degree. We have custom linting frameworks, custom compilation frameworks. We do app size magic that nobody else has. And we have this problem where we clever our way out of everything. But at some point, that is really foundational, cutting edge work that has been done to facilitate these gigantic products being broken down in these tiny little bite-sized chunks that can both be compiled locally, developed against, debugged, but also shipped to our users without it being the only thing their phone can do.
It takes a minute to even know how to respond to a statement like that, right? Because just the complexity of each of those little pieces all working together. But then the fact that it actually works is kind of and works so well, I think, is kind of what's so impressive.
Any more questions?
Exaggerating when I say it's the most complex Android code base that I've ever seen, and I've seen a lot.
And that was one of the first questions, actually, was elaborate. And I feel like you've done that kind of for the whole session. Is like, yeah, there's complexity here, there's complexity here, there's complexity here. It's not just the code, it's not just the architecture, it's the whole process of manufacture and everything that goes into it. Yeah.
Justin, how many more can we take before
we
wrap it up? I know we have so many.
I know, and we're going to spill stuff over into the Slack. So again, I'll post that before we close out again. So make sure that, and you can scroll up in the chat now if you see that now.
Maybe pick two of the top ones, Justin, and Adam will go over a bit, and we don't want to abuse your time. We could, probably extend this to all day. I could just cancel the rest of my meetings and.
It's not the Joe Rogan podcast, but
I think here's one that I think is really good because I think it ties into some ambiguities that people get around the process of developer productivity engineering versus kind of management. And I think it's just a good opportunity to disambiguate that what we're talking about here is using technology to make productivity better through happiness and less frustration. But one of the questions was, don't you think too much measurement feels like micromanagement for engineers? Maybe you could tell me a little bit about culturally. Yeah.
So I've got the perfect answer to this one. If you haven't ever heard of Goodhart's Law, you should look it up. What Goodhart's Law says is that as soon as a metric becomes a goal, it ceases being a good metric. Now we take that to heart, and we take it to an extreme, really, where we don't say you need to write this much code or spend this number of hours. We don't say there are this many requirements for how many lines of code get written or how many diffs get put through. What we do is we look at the effect of a given change on all of those metrics. And we don't say they have to be a certain number or arbitrarily say they need to improve. We look at it from an evolutionary perspective where those things are positive direction. So when we put in a change like balance spot, we say, okay, are these things that are generally neutral goods improving? Are we getting diffs through faster? Are diffs landing better? Are there being more thorough review and less reverts? Are the average regression that a diff causes against all of the company financial active user, those kinds of product metrics, is the average effect of a diff getting better? We don't care how it gets better. We don't really care if the way it got better was that you had to stand on one foot and dance under the moonlight. That doesn't matter. What matters is that you ran an experiment that shows that by doing this thing, whatever it is, all of those other things net went better. And better is the whole point. Better is the way we get to functional and the way we get to efficient. Even little steps, if you do them long enough, will get you where you're going. Now, that always brings up the problem of how do you choose which thing will give you the most impact? And that's a whole problem in and of itself. And it's sort of the most difficult thing that we ever have to ask. But rather than asking, how can I possibly do that? We're asking which of these things that I could do are going to have that impact. And because we're constantly measuring, we can decide whether we were right. And that helps us tune that whole process. But we never goal. We never goal. Never goal on productivity or on individual output as a thing a person needs to do. That's not how we measure our engineers. It's not how we measure our people. We measure them on the impact that they have to the organization and to the products and to our users.
That's quite possibly a perfect answer. I mean, I love that. It's like, no, these metrics are not here because we want to drive them necessarily in any particular direction. These metrics are here so that we actually know what we're doing and we can make informed decisions. So I know we're up on time. I just posted the community Slack channel again to the main chat, and we can fold in there. I'm going to do my best to get these things, the remaining questions in there, and then Adam can asynchronously, as he has time, respond to so many of these amazing questions. I mean, really, we need another session, I feel like, because there's so much that we could still discuss. So, but Ruz, why don't I hand it on back over to you and we'll close.
Just wanted to thank Adam for his time, and of course, their team is hiring, right? Thank you for Facebook Engineering for allowing Adam to speak and share all this with us, right? There's a link, QR code to link for the jobs within Adam's org, right? If you're interested. And Adam, thanks again. I mean, we go all day, and thanks for, giving your time to go into the Gradle community Slack and share all that there. And with that said, you got anything for our folks before we go?
Well, I'll just say that the way we think about Android and iOS is not like the way everybody else thinks of Android and iOS. We want talented Java and C developers. The fact that our code is running on mobile is not the critical part of any of this. As much as that's valuable, if you've ever wanted to work at Meta and Java or C or Swift, mobile is a great way of coming in because we look at mobile the way most people look at servers.
Yeah, that's awesome. And folks, the moral of the story, if you don't invest in tooling, productivity, engineering, developer experience, and one day you ended up competing against Facebook, send thoughts and prayers, right?
That's perfect.
And that's why we're here today. And thanks again, everyone, for joining and spending this time with us. And thank you, Adam. Thank you, Justin. Thank you, the Gradle team. And we'll see you all on the next one, which Android X, how the Google Android X productivity, how the Google Android X team does productivity engineering. We're doing a webcast on that with Armis from the Android X libraries team. They're the folks behind Jetpack. Thanks all. Thanks, Adam. And we'll see you all next time.